We have our next speaker from KTM Technologies. We'll be addressing the challenges of additive manufacturing and the development of lightweight parts and much more. Please, a round of applause for the Senior Engineer in Additive Manufacturing, Dr. Adrian de Blas. Hello.
Well, good morning, everyone. Thank you very much for this invitation. We are really happy to be here. Say to the organization people that many thanks for what they did to bring us today here. So, thanks. What I want to show you today, or what I want to share, is the vision of my company, KTM Technologies, in the field of additive manufacturing of polymers. Just to bring you a little bit to the background of the company, we are part of the KTM Industries group. Our company basically is working for the technology development inside the group. And what is really nice of this partnering is that we know that the work we realize, that the projects that we are carrying out, they end field in the industrial sector, in the cell production, or in motorsport. And that's pretty exciting and motivating for us to carry out new projects in the field of technology development. And our company, it's pretty found on this field and as an incubator for the group KTM and research on the new concept development of vehicles. For example, we started in 2008 with the development of the crossbow car. And we currently focus in the same idea of developing new cutting-edge approaches. We cover the whole process chain since the early stages, from the research, the concept development, to the final industrialization of the parts. And at the stage of technology development, which actually is the department I work, we are pretty focused in facing the challenge of composites and lightweight. And we use a pretty good knowledge in the material characterization and testing. Inside this department, my group, Additive Manufacturing Group, we are pretty focused in much more of what it's taught in this sphere, but as a way to emphasize what it's all different with the respect of the competitors. We pretty work in looking for optimized solutions for parts based on hybridization. In the hybridization of additively manufactured parts together with carbon fiber reinforced plastics, and how to look for optimized part that could bring us the solution in this case. Of course, regarding this, we actually, in the first stage, take a really good and deep research in the new concepts in terms of materials present in the market, the new technologies, and the new processes. So to give you an overview of what's our facilities, we can use all the facilities from the KTM group. It's more than 18 different systems, 4 technologies, and in a total, more than 12 different materials placed around Austria. We are placed in Salzburg. This is our city, and we are together with Kiska. It's a design company, which actually we partner a lot in terms of design. And also in the headquarters of KTM in Mattighofen, but also the SLM technology that we use in Kapswembe and with the parking systems. So coming back to the topic that brings us today here, what was about when I started in the company thinking about how could we introduce the use of AM polymers in the industrialization. And we thought the best. We did the test to think about what was the first factors we should take into account. And for sure, quality assurance was coming, overall safety, the economic viability, and the process repeatability. But at the first stage, what can make us think about using additive manufacturing was to, okay, we have a problem, we should at least fix it with a material that has the same performance that the current one. So if we are trying to substitute traditional ways to manufacture it by additive manufacturing, we have to ensure that the material performance is still the same. So we took a look in our field with the knowledge we have and in our company, and we took a look at many different plastic applications that exist, not only for street bikes, for off-road, for enduro motorbikes, motocross, and we realized that many parts, they could be benefit of the use of additive manufacturing because, for example, in motorsport, we are also demanding always of the late time, but also so many complex geometries that are really tough to be manufactured currently with induction molding or roto molding. We could get the benefits of using additive, but why we were not using it then? Well, take a look, and we saw, okay, this is the tendency of these material properties that I show you here. Those are only two values, but we have to consider many things as the anisotropy behavior of additive manufacturing. We have to consider different aspects as the repeatability of the parts that we are getting. But just focusing these two, we compare with the current situation that we have for the commercial available materials, and we realize, oh, wow, there's a gap still, and we need to solve this problem. So how we thought about solving this problem and actually bringing a solution, and in our company, of course, it's a solution that it has to be lightweight, but it's for a functional part. We thought about the word hybrid, and that's what we thought. And to achieve this goal, this far away aim, we said, okay, we need to start with two strong pillars. The first pillar is additive manufacturing, like bringing us huge advantages like freedom in design. But we have to say that we have to really ensure the material performance. And that means not only getting material information from suppliers, but also to characterize this material. The second strong pillar is the use of composites, the carbon fiber reinforced plastics, and where my company is real expert in this field. But we thought, how can we merge them? Do we need a connection? So this is the bridge. This is the hybridization. And about this, KTM Technologies has developed a technology with the name of Connexus. You can know more about this in following congresses, and also how they prepare the introduction of this into industrialization with the project Next. But we don't forget about all the pillars that are important in additive manufacturing, like it's the simulation, the use of design for additive manufacturing, a proper way to design parts for additive manufacturing, and a proper production and testing, but are four common pillars that we really still have to think about the first ones. And when we were told to come here, we thought, okay, how can we show these people what's the real benefit and the potential of using hybridization? How can we tell them that this is a real way to face the challenge? And we thought, okay, let's prepare a part that we could show them all how we have a part in AM polymer, and it could not fulfill the requirements of a load case. And then let's make a reinforcement of this part by C4Ps. And let's make this also a case that we can make an optimization to show our creativity making that. And that was the result. After 21 weeks, we achieved this result. It's a part that mimics the same shape of a KTM motorbike brake lever for street bikes, and which also includes some features for additive manufacturing, like lattice structures and the topology optimization. But the new thing, or the brand new here, it's that we were applying optimized load plate-based distribution of unidirectional carbon fiber surrounding a three-dimensional complex surface. So I will give you an overview how was this project taken in the company. It's not that easy that only plug and play using a software and define a loading case and the constraints to get a proper final design that you can define as a functional part. Because also, in this case, we had to take into account the hybridization topics. We have to also care about aesthetic problems and, of course, the different technologies that we could use to produce it. So, when we start the project with a strong base in the phase one, we start researching in which materials, existing materials, we could use for this. And we define, OK, let's make a criteria from which we will start or a starting point for the design. And this case was to use the ISO 8010 for motorbikes brake systems. And we will withstand the load case at the criteria that this ISO is asking for us. So then we define a basic geometry based on a topology optimization for aluminum part. It was made, this reference model, in aluminum. And then we decided, OK, let's make and create a first concept, and include in this concept the lattice structures. But many of you that are also fighting with this, you realize that the computation, the modeling of lattice structures is not that easy as we were expecting, and it's really time-consuming for a company to successfully achieve a final simulation. So what's different here, what we did is to actually characterize the behavior of lattice structures. We create a library of different unit cells, and we make a characterization of this. And then we base our selection of these lattice structures based on the behavior or the results that we took from the testing. So after this, we go to the proper design. And in this case, although I show you here, these two phases, phase 2 and phase 3, they are overlapping. They are in continuous iteration. The results from the simulation are coming to design, and they are coming back to the results of simulation to make a proper and optimized simulation. And in this case, what we emphasize is that we are not using the mechanical properties that we receive from the suppliers, because those properties are not really evaluated in all material, in all house, in all technology. So what we do is to use our test specimens to properly characterize them, obtain the real properties that we will get these parts, and then use this information, the difference that we can have in the same bow job, in the same printing job, sorry. So all this information, we get it into the loop for the simulation. In the meanwhile, we make the networking to get collaborations, partnering, future suppliers of different technologies that could fit all requirements for this project. And as you can see, we start making the loop and iterations in design. So at the end of this phase, we add the last design features or the last aspects in design, and we make a functional assembly check. And we can see here in the real motorbike, OK, this part will be working and similar as it should. We already achieved an optimized simulation of a part, how it would work for this case. After this, and we have already defined what are the criteria, we select which is our final design, and then we go through our suppliers or our partners to send them the information to finally get a part. In this case, we use 5 different materials, 4 different technologies, because we were looking to actually ensure which will fit perfectly in terms of the hybridization and the combination of the composites together with our core part. So that's why we went to a benchmarking project as well to show which material will fit or will benefit of this hybridization. We include in our technology and, of course, a stage of surface finishing that I will let you know more about this, how tough is actually get a proper surface finishing for a functional part. The last phase is, of course, to ensure the geometry accuracy by 3D scanning, so we can compare the accuracy for the different technologies, and for sure, of course, validating the load case that we suggest at the beginning for the criteria of the ISO. So after this, what we achieve and what we are looking is to not only demonstrate you what we can hybridize and combine, but also we are always looking for parts that we can ride. And actually, when this end, what we did was first thing was testing, because we validate our part. And that's what I like to demonstrate, that we are looking for maybe future groundbreaking solutions that are still not for the current situation of the market to get into a zero production, but we are looking actually for parts that we could really use in our market base, in our business case. So you can see here more in slow motion my driving test driver, sorry, how I use it. And actually, he reported us that the filling was proper filling of the same brake lever that he was using in aluminum. It was the same filling. In this case, the brake lever was only 35 grams in the final for this material. But as I told you, we did a benchmark, and also in this project, we consider different materials, and we define actually what it will fit us for a future project. And for this part that you can see also in our stand later, if you want to pass by, we make our final report of the results, of course, that we can provide to our decision makers in the group. And we show them this actually interesting results. For this case, in the case of successfully achieving the criteria of this ISO, we got these parts, and the material from 1 to 4 are the hybrid cases, and the material 5 is the case of aluminum that we replicate also in SLM. And in this report, what we can see is also it's pretty important to make a proper surface finishing of the part and obtain a functional real part. We have to really spend different efforts depending on which material we are using, depending on which technology are we using. And in this report, you can see these complex differences. But when we have the solution from material 1 to 4, and you can see, OK, material 1 is the cheapest one. Why couldn't we use it? OK, it's not only about cost, of course, in a business case. And depending on which organization or what's the aim of the project in additive manufacturing, you have to properly analyze. So this is a summary of our analysis that we report to the stakeholders. But as you can see, depending on which will be our aim to satisfy the application, if it was lightweighting, or if it was to have a real proper accurate part, or really achieve the best hybridization possible, we have to look into different solutions depending on the material and, of course, the technology. Because it's pretty important. Here, I'm showing the values of printing speed, but it's not only about printing speed. It's also about post-processing. Different technologies require different post-process, and maybe the printing speed is really fast, yeah. But maybe you need double the time for making a proper post-process and to obtain the final properties of the part. That's pretty important to consider, because this is also energy wasting, time you're wasting, and it's an important thing to include in a value chain for additive manufacturing. So to give you a final overview of what was for us this project, and then with these ideas of this project, you can also get your own conclusions about what's the best potential of this hybridization concept. It's that we finally got a technology demonstrator with the shape of a brake lever. And this hybrid solution presents a 40% increase in the lightweight factor comparing to the aluminum one, if we focus on achieving the criteria of the ISO. And another interesting point is just making this project, we successfully characterize different lattices unit cells that we could use for different other projects. And that's pretty important, given this current state of the art of the computing of lattices. Fourth point, it's we did good research in materials, but we also create our own material cards. That means we really characterize the materials for polymers in different technologies with our own testing methods in-house, so we properly ensure that we are next time prototyping, it will ensure the mechanical properties that we got in this testing. And for the last one, we current developing more the technology of hybridization, but this project was actually a huge step forward to successfully achieve a great chemical bonding and hybridization of the materials. Looking forward to a functional real part into a market. And to involve and to summarize everything, this project was done in 21 weeks. So it's a good example of the benefits of additive manufacturing, how fast can go in a project. Nothing else to say, just to encourage you to contact us with any question, doubts, your motivations. All of you that you are already facing challenges like this, we are really willing to help you. And just to let you know, part of the content of this presentation was already uploaded in our website. You can check our QR code that is in our stand. You can make the scanning, and you can link to the website so you can download part of the content. Nothing else. Thank you very much for your attention, and thank you for the organization of this. Yeah.